All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course and we're still doing our learning module. Let's have a look at what we went over tonight. Now, last night, if you recall, we started the process of formalizing our model. Let me go up a little bit so you can see which one I'm talking about. This one here. So, tonight, we're just going to build off of that and pick up what we left off. So before we get there, let's try to formalize this a little bit more mathematically just to get a sense for how it is that we'll often see this if we ever go further into supervised machine learning and explore this idea. One thing generally for these categories, we'll sometimes just use the names of the categories like rain or not rain. Often mathematically, if we're trying to do comparisons between these things, it's easier to just delve into the world of numbers. So we could just use the expression below, for example. We have 1 if weight 0 plus weight 1 times input 1 plus weight 2 times input 2 is either equal to or greater than 0. Otherwise, 0 otherwise. So this is a so we do all this math, and if the result is greater than or equal to 0, we'll go ahead and say our hypothesis function output is 1, meaning raining. Otherwise, it outputs 0, meaning not raining. And oftentimes, this type of expression will instead express using vector mathematics. And all a vector is a sequence of numerical values, something like this here: the w0 plus w1, x1, and so on and so forth. So we could represent that in Python using something like a list of numerical values or a tuple with numerical values. Here we have a couple of sequences of numerical values. One of our vectors are all of our individual weights. So let me go down a bit further so you can see that. So this is our weight vector. So we can construct what we'll call a weight vector. So we have weight vector W0, W1, W2. And we'll see why this is useful in a moment. We'll call it W, generally using a bold-faced W, and it's just a sequence of our three weights. And to be able to calculate based off of these weights, whether we think a day is rainy or not rainy, we're going to multiply each of those weights by one of our input variables. For example, W2 is going to be multiplied by X2, W1 is going to be multiplied by X1, and W0, well, that's not going to be multiplied by anything, but just to make sure the vectors are the same length, we'll say that W0 is being multiplied by 1. So in addition to the weight vector, we'll also have an input vector, X, that has three values. So our input vector X here has 1, X1, X2. And if you recall, we have this 1 here because W0 gets multiplied by 1. So X1 would get multiplied by W1, and X2 would get multiplied by W2. So here we have represented two distinct vectors, a vector of weights that we need to somehow learn. The goal of our machine learning algorithm is to learn what the weights vector is supposed to be. We could choose any set of numbers and it will produce a function that tries to predict rain or not rain, but it probably won't be any good. What we want to do is come up with a good choice of these weights so that we're able to do an accurate predictions. And then our input vector represents a particular input to the function. A data point for which we would like to estimate, is that day a rainy day or is that day not raining? And that's going to be vary depending on what input is provided to our function, what it is that we are trying to estimate. And that's we went over tonight. We went over a lot more, but I'm not going to do a lot of reading tonight. But we will pick it up tomorrow, and of course, I will keep you guys posted every step of the way. But as usual, this is the Python Papi. You guys stay Gucci.